Hello, welcome to our first activity of the first module for the GRE Math Preparation course. What you're going to want to get yourself set up with is a peaceful, quiet environment. You'll want the packet of materials for the first module ready to go, and we're going to use specifically the Building Fractions and Decimals worksheet and the key. You'll want a pen or pencil and a straight edge. Follow along with me as I work through this activity, building understanding of how fractions were developed in the first place through thousands of years of human history. If you're like my students in my college math and my Math for Elementary Teachers course, you'll also build a deep, rich understanding of fractions and find them easier to work with as we move into the next activity, which is taking GRE type questions and applying these concepts. So let's go ahead and get started. To start with a fraction, before we have a fraction, we have a whole item. So on our worksheet, we see we start here on the left-hand side with one whole. What we're going to do is we are going to divide that whole into about half. This was the first process that humans have found it fairly easy to take something and cut it in half. So I'm actually just going to take a line all the way across. And what I've done is I've taken something that was whole, one piece out of one piece, written as a decimal, 1.0, and I've divided it into two pieces. So instead of calling them two wholes, though, what I do is I recognize that they came from something else. So I've got 1 out of 2 and 2 out of 2 pieces. And that's the beginning of fractions. The next step is we would take each half and then we can divide those halves in halves. So I'll come here, and again, it's a fairly, I won't say easy, I don't like to say anything's easy, but it's a fairly natural thing to divide things in half. And so what we now have is we have 4 pieces, and we will name them 1 out of 4 or 1/4, 2 out of 4 or 2/4, 3 out of 4 or 3/4, and 4 out of 4 or 4/4. So we see we're back to a whole. The next step would be to take each of these fourths that we have and divide them in half. So we come along here and we're dividing each of the fourths in half, and hopefully you're doing a good job of making them exactly equal. Again, it's a little bit challenging, but we're doing our best. Okay, so what we see now, we've got 8 pieces, so I've got 1/8, and this is just sort of counting. 2/8, you see where fractions come from. 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. And my squares are a little bit off, but it's okay. And one more time, we found that sometimes the need to take these smaller pieces and cut them in half. So we'll go along here, each of these 8s we'll cut in half, and you got it, we'll get 16 pieces, and each one will be 1/16, and we'll just go ahead and count along the way. And we notice that they're getting smaller and smaller. It's getting harder to write into each of these. But notice we're just dividing things in half. The simple process of dividing things in half is what all of mathematics is really based on. So then we've got 1/16, 2/16, 3/16, 4/16, 5/16, 6/16. As we're going along, we're starting to see some that are what we would call equivalent fractions. So while you don't usually work with 6/16, you convert it over to 3/8. It is a way of counting through the fractions. More natural, more using the whole numbers that we're comfortable with working with because we've learned them as young children. 8/16, 9/16, 10/16, 11/16, 12/16, 13/16, 14/16. I know it's tedious, but important because as we're doing this, we're solidifying our understanding of what fractions are. 16/16. Now in modern times, they'll even divide those in half. You'll get 32nds and 64ths. But what you've noticed is here's one system of just dividing things in half, and then the half in half, and then half of the half, and so forth and so on. You could go back with your calculator and divide. Take 1 divided by 2, and that gives you the decimal 0.5. Take 2 divided by 2, and you get the decimal 1.0. Take 1 divided by 4, and you get the decimal 0.25. 2 divided by 4, and you get the decimal 0.5. So we see now on a decimal representation how 2/4 and 1/2 are equivalent fractions. 3 divided by 4 gives us 0.75. And 4 divided by 4, we're back to our whole, 1.0. And that's going to be an important concept, working with the whole. 1/8, we get the decimal 0.125. 2/8, we get 0.25. 3/8, we get 0.375. 4/8, we get 0.5. 5/8, we get 0.625. 6 divided by 8, we get 0.75, another equivalent fraction. 7 divided by 8, we get 0.875. And 8 divided by 8, we get back to our whole of 1.0. I used to be a loan processor for mortgage loans, and if you look at interest rates on mortgage loans, they go by eighths. So you just get used to picking up these decimals because you see them so many times. Okay, so now we're going to start over with another way that we could have divided things. Okay, again, another different way to do this is we could have started out with 1/1, which is 1 whole, and then we need to share this among 3 people. So we're going to divide this not in half, but into 3 equal pieces. And again, this is something it's a little harder than dividing in half, but it's not too hard. It's sort of a natural process dividing into thirds. So I'll go, that's about 1/3. And I think if I go about here, this looks like about 1/3. So what I've got is 3 somewhat equal pieces. 1/3, 2/3, and 3/3. What people did from this point, instead of continue to divide everything in thirds, they moved on to dividing the thirds in half. So kind of going, it's a combination of the 2 systems. So then the next step is to take the thirds and divide them in half. So divide each of the thirds in half, and what we have now is we have 6 pieces. So again, we start with the counting. 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. And one more time, we're going to come along and divide these in half. So each of the 6 will get divided in half. So we start off by dividing into thirds, and then we divide everything else into halves. What you're going to see is that this gives us a way of understanding math visually, because we've drawn each of these. We've gone through and labeled each, so this is 1/12, one piece out of 12. This is 2/12. This is 3/12, and so forth. We keep counting 4/12, which is the same thing as 2/6, which is the same thing as 1/3. So we see that equivalence right there. 5/12, 6/12, 7/12, 8/12, 9/12. And notice kind of when you get the odd numbers and the even numbers, 10/12, 11/12, which is going to be another thing that will run through our activities, even in odd numbers, 12/12, a whole. So that's what gives us the whole. And again, we can go back and turn these into decimals. 1 divided by 3 gives us 0.3, and a lot of these after that 3 repeating, so we put a bar over the top. 2 divided by 3 gives us 0.6 with a bunch of 6 afterwards, so 6's continue to repeat. But then when we get to 3 divided by 3, that gives us our nice solid 1.0. 1/6 gives us the fraction 0.16 with the 6 repeating afterwards, so we put a bar just on the 6. 2/6 is going to be the same as 1/3, so you'll see that that's 0.3 repeating. 3/6, well, that's one that actually ends up being a nice value. It's 0.5. It's a half. 4/6, we're back to 2/3. It's the same thing, so we get 0.6 repeating. 5/6 gives us 0.83 with the 3 repeating. And finally, 6/6 gives us 1.0. And the 12ths we'll see on the answer key because we're running out of room to put them in there. Especially in the American system, because of the way we built things, if you look in your refrigerator, you're going to see bottles that have 16 ounces in them, or possibly the cans that have 12 ounces. Look around your world and you see the 16 and the 12s, the 8s, the 4ths, the halves, all around us, because these two systems were used to develop our whole number system. In fact, if you measure in feet and inches, what you'll find out is these two systems are intertwined. The feet were divided into 12 inches using the second method that we've developed over here. But inches are not divided into 12ths. Inches are then divided into 8ths and 16ths. So you can go down to a 16th of an inch. So it's a combination of the two. And then there's finally one other process that has been used by mankind to come up with mathematics. And that is the last one we're going to take a look at. So again, we start with one whole, 1 out of 1, or 1.0. And in this instance, what we're going to do is we're going to divide this one whole into 5 pieces. So it's a little bit more challenging, but if we come over here we've got our fourth, a fifth is going to be a little bit smaller than a fourth. Notice as the denominator gets bigger, the pieces get smaller. So that's going to be another concept you're going to want to take with you as we work through the GRE. So I'm going to call a fifth about here. And again, a fifth is not too hard to come up with, but it's a little bit more challenging. Here's another fifth, Let's see if I can get that same amount. Here's another fifth, and then let's see if I go about here. So the key part, I've got 5 pieces. Hopefully they're equal. 1/5, 2/5, 3/5, 4/5, and finally 5/5. The next step was not to divide these to 5 pieces again, but there was a switch made over to dividing the fifths in half. So notice that was kind of built off of this second one as well. So we take each of the fifths, we'll divide it in half. And you're right, we're going to get tenths. This is the decimal system, the metric system that is used throughout the world in every place except the US and maybe 1 or 2 other small countries that have used some other system. This is a system that was developed in ancient India 3,000 to 5,000 years ago, or at least well in use, and it is the modern system that our mathematics is based on. 2/10, 3/10, 4/10. We're just counting along 5/10, which if we come along here we'll see is also 1/2, 6/10, 7/10, 8/10, 9/10, and 10/10. So we'll come back here and we'll fill in with some fractions. So 1/5 is 1 divided by 5 is 0.2. 2 divided by 5 is 0.4. 3 divided by 5 is 0.6. 4 divided by 5 is 0.8. And 5 divided by 5 is 1.0. And then we'll do each of the tenths, which really shows you the ease of the decimal system. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1.0, 10 divided by 10. So these are the ones that we use. Let's again, if you have bottles in your fridge that don't have 12 or 16 ounces in them, you might find that they have 500 milliliters or 1 liter. So they're divided up using the metric system, which is this last one. So these 3 systems, the first 2 kind of intertwine and get used together, whereas the last one is a method of mathematics that stands on its own. Now just a note, there's 2 different options that were used with this. Some societies, the Aztec, the Mayan, and actually French, if you look at it, what they did is they took the tenths and they divided them in half. And so then you would have 20 pieces. And they have a mathematics that was based on the number 20 being the complete number. Others took the tenths and divided them into 10 pieces each. That's the system from India. And so then you got hundreds and then thousands in our whole decimal system. So we'll leave that off, but it's all based on these 3 different methods, these 3 different systems. So what we'll look at next is just pull up the key that has everything written up for us. We won't save this. And so it's all nicely printed with the decimals and the fractions for you to kind of make reference to as we work through things. But again, going through this process, going through this activity, we'll build on this as a foundation, and you'll see that it'll be easier to answer the GRE questions that we have coming up in the next activity. So I hope you enjoy this. Take a little break, and then we'll move right into the next activity, which will take these concepts and apply them to fractions, ratios, decimals in solving GRE problems.